In this recording, we will discuss the anatomy of the lower respiratory tract. We have successfully taken air from your nares through your nasal cavity, through all three sections of your pharynx, and down into your larynx. The next stop is the trachea, also known as the windpipe. Okay. This begins in the inferior region of your neck and extends all the way to the mediastinum. So you've got the lower portion of your neck to your mediastinum. Okay. This is composed of hyaline cartilage rings, which cover the anterior region and lateral surfaces of the trachea in a C-shaped fashion, but the posterior surface is left uncovered. And if we flip to the next slide real quick, we can see what we're talking about here. This blue is your hyaline cartilage ring. It's like a C shape, and the back portion, the posterior region, is not covered by that cartilage. We'll talk about that in just a second. At the end of the trachea, we come to the carina, which is a branch point. From this point on, we'll branch into the primary bronchi, both left and right. We do have mucosa within the carina that have sensory receptors that will trigger a violent cough reflex if foreign materials come into contact with those receptors. This is really just a last-ditch effort, so if something foreign makes its way all the way down here to your carina, we have one last-ditch effort of trying to cough that back up. If we are unsuccessful, or if something just doesn't trigger those sensory receptors and continues on, it will make its way into the lungs themselves, which we are trying to avoid. Now, the mucosa of the trachea is basically continuous from the inferior larynx. We have pseudostratified ciliated columnar epithelial. We've got a bunch of goblet cells here since this is mucosal tissue. You can see here very clearly the little cilia, and I think those are kind of cool. There we go. Now, those tracheal rings that we mentioned, they are supportive enough to keep the trachea open, also referred to as patent, but they are flexible enough to allow the trachea to change in diameter during pulmonary ventilation. So if we need to bring in extra oxygen, perhaps during exercise, we can expand this, the diameter of this, because we've got a little bit of smooth muscle here, so we can take in extra oxygen. The posterior surface, we said, was not covered in the tracheal rings, the cartilage. Instead, it is that smooth muscle. We just mentioned that it does allow to change the size of the diameter, okay, of the lumen for the trachea, but it also does this during swallowing as well. So the esophagus sits right behind your trachea. So if you're swallowing, I don't know, just a really big piece of food or something, we wouldn't want to potentially damage the cartilage. So if this were also cartilage and we swallowed something really big, we could potentially cause damage there. But since this is smooth muscle, it would be much more flexible here. Every time we swallow food, there's really no concern with damaging anything. Now, that smooth muscle itself within the trachea is innervated by your autonomic nervous system, which I'm sure will not come as a shock to you at this point. Under stress, your sympathetic nervous system kicks in and we activate bronchodilation. So we increase the diameter and we take in more oxygen. At rest, your parasympathetic nervous system takes over, which causes bronchoconstriction, which really just allows the diameter to go back to original shape. Okay, we're not really going to go extra small. Okay, we're just going to go back to the original. Now, once we hit that carina, we mentioned we are going to branch off into the bronchi. You have both a left and a right primary bronchus. Okay, so bronchus is singular, bronchi, or that's plural. This is how you get into the lungs themselves. Okay, so where the bronchi enter the left and the right lung, we call this region the hilum. Okay, you will see the term hilum on a couple of different organs as we go through the anatomy of the body. And anytime you see the word hilum, it's really just referring to where things like bronchi, vessels, nerves, things like that enter and exit the organs themselves. Okay, so you will see the term hilum a couple of times. So once we get inside the lungs, okay, your primary bronchi will start to branch. We have a bronchial tree, and you can see very clearly that we have quite a bit of branching. These branches get progressively smaller until we reach the level of the alveoli. The alveoli are the smallest structures within the respiratory system themselves. So your primary bronchi are going to begin right at the carina. Okay. There is a little bit of a difference anatomically with the right versus the left because of your beautiful warm beating heart. Okay, so the left side is just a little bit different. So if you can imagine, your heart would sit right about here. Okay. Make sure I said all that. Okay, so your right one. All right, so right primary bronchus is wider and shorter and straighter. Okay, so your heart doesn't sit on the right hand side, it sits on the left hand side. So we can immediately go from carina, boop, right into your right bronchus. Okay, your left primary bronchus has all of our other adjectives. It's more narrow, it's longer, it's more horizontal because of that nice warm beating heart we just mentioned. Because the right side is wider and shorter and straighter, it is more likely that you would inhale something and it end up on the right side versus the left side. So just a fun fact there. Now, once we get past the primary bronchus, we immediately start branching into the secondary bronchi. Within the lungs themselves, you have 3 on the right side. We only have 2 on the left side. Coincidentally, you have 3 lobes to your right lung, and you only have 2 lobes to your left lung. Okay, so there might be some good functions and purposes going on there. The secondary bronchi, each of them will then branch into tertiary bronchi. You get approximately 10 tertiary bronchi per lung. And then we are just going to keep branching and branching and branching. And eventually, boop, we get to the bronchioles themselves. Okay, so we have primary bronchi, secondary bronchi, tertiary bronchi, and then we get to the bronchioles. Okay, these are your smallest airways. They look quite a bit different than the larger airways. We have now transitioned into simple cuboidal epithelial tissue. We don't really have cilia anymore. If you end up with some sort of foreign material way down in your bronchioles, you're not coughing that back up. All right, so there's really no need for cilia at this point. They are enclosed with thick rings of smooth muscle. Okay, we don't have any hyaline cartilage here. So any kind of junk that does make its way into your bronchioles will probably make their way into the alveoli. We have macrophages that live within the alveoli to help fight any kind of pathogen or anything like that that might have made its way that far down. If it's something too large for a macrophage to deal with, you may need to seek medical attention, something like that. We have 2 different regions way down deep here. We have your conducting zone. The ends, when inspired air reaches your terminal bronchioles. Okay, so we've got primary, secondary, tertiary bronchioles, then we've got terminal bronchioles. Okay, the terminal bronchioles will then continue to branch into respiratory bronchioles. Okay, which are also surrounded by smooth muscle. These smooth muscle layers are what constrict during an asthma attack. So this would drastically reduce the diameter of the respiratory bronchioles, which makes it much more difficult to do gas exchange, which is why people have a really hard time breathing when they're suffering from an asthma attack. The respiratory zone itself begins with the respiratory bronchioles of the alveoli, and continue through the alveoli here, which are these little grape-like sacs. Okay. Each respiratory bronchiole branch into alveolar ducts, which then branch off into alveolar sacs. And so it's just nice, one nice continuous tube basically. So we've got our terminal bronchiole, and we've got our little dividing line here. And so this would be your respiratory bronchiole. And we're going to branch just a little bit more into your alveolar duct, which leads directly into your alveolar sacs. Okay. Your alveolar sacs, each of these little grapes, okay, this is where gas exchange occurs. Okay, so we have quite a long pathway for air to reach the ends of these little alveolar sacs to actually do gas exchange. So just in case you have forgotten the pathway, okay, we've gone through a lot of structures. We inhaled air at the nares or the nostrils. We've moved through the nasal cavity, through your naso, oro, and laryngopharynx. We've gone down through your larynx into your trachea. At the carina, we split into your primary bronchi, both left and right, which divided into your secondary and tertiary bronchi. Okay. We have continued to branch until we get to your bronchioles, all right, which lead to your terminal bronchioles. All right, now this is, remember, your dividing line for your conducting zone versus your respiratory zone. So we reach your respiratory bronchioles, which divide into your alveolar ducts, which end at the alveolar sacs. This is finally where gas exchange occurs. And just one last more time, here we go, real life picture of your alveolar sacs. You can see all of this empty space, which allows air to come in to do gas exchange. You can see all these little capillaries, these pulmonary capillaries, okay, where we would actually do the gas exchange itself.